In this question, we are given a triangle with sides AB, BC, and AC. To find the area using Heron's formula, we first need to calculate the semi-perimeter, S, which is half of the sum of all the sides. The sum is 9x, so S equals 4.5x. Now, we calculate the differences between S and each sides. S minus AB equals 2.5x, S minus BC equals 1.5x, and S minus AC equals 0.5x. Substituting the values, we get the square root of 4.5x times 2.5x times 1.5x times 0.5x equals 50. Then, we square both sides of the equation. Solving for x equals fourth root of 2,500 over 8.4375. Thus, the value of x is approximately 4.15. In this question, we start with the expression f of x equals 2x squared plus 4x plus 9. We factor out 2 from the first two terms to get 2 times x squared plus 2x plus 9. Now, we focus on simplifying the expression inside the bracket, x squared plus 2x. We recognize this as part of a perfect square. We can rewrite it as x plus 1 squared minus 1 squared. Now, the expression becomes 2 times x plus 1 squared minus 1 plus 9. Simplifying further, we have 2 times x plus 1 squared plus 7. Now compare this expression to the form a times x plus b squared plus c. From this, we can see that a equals 2, b equals 1, and c equals 7. The function 1 over f of x reaches its maximum when the squared part, x plus 1 squared equals 0, because the square of any number is always non-negative. For x plus 1 squared equals 0, we have x equals negative 1. At x equals negative 1, the maximum value of 1 over f of x is 1 over 7. In this question, the given summation is the same as 2 plus 7 plus 12 up to 5n minus 3. This forms an arithmetic sequence where the first term 2, the common difference 5, and the last term 5n minus 3. The formula for the sum of the first n terms is n over 2 times first term plus last term. Substituting the first term 2 and the last term 5n minus 3 into the formula, we get n over 2 times 5n minus 1. Moving to question B, we are told that summation starts from 152 and ends at 297. There are 30 terms in this sequence. To find the sum, we use the same formula. 30 over 2 times 152 plus 297. Simplifying, we get 6,735. Moving to question C, the sum of first n terms is 3,783. So, n over 2 times 5, n minus 1 equals 3,783. To solve for n, first multiply both sides by 2 to eliminate the fraction and expanding the bracket, and rearranging the equation gives 5n squared minus n minus 7,566 equals 0. Now, we solve this quadratic equation using the quadratic formula. This gives two possible values of n, 39 or negative 38.8. Since n must be a positive integer, the only valid solution is n equals 39. We are given two rates of change, dA over dt equals 50 pi and dr over dt equals 5 over 12. Our goal is to find the volume of the sphere. The formula for the surface area of the sphere is A equals 4 pi r squared, where r is the radius of the sphere. To find the relationship between the rate of change of the surface area and the rate of change of the radius, we use the chain rule. We know that dA over dt equals dA over dr times dr over dt. From the surface area formula, we can find dA over dr equals 8 pi r. Substituting the values into the chain rule equation, we have 50 pi equals 8 pi r times 5 over 12. Solving the equation gives r equals 15. The formula for the volume of a sphere, V, is 4 over 3 pi r cubed. Substituting r equals 15 into the formula gives V equals 4,500 pi. Thus, the volume of the sphere is 4,500 pi cubic units. We know that velocity is the integral of acceleration. When we integrate the acceleration, we get velocity equals 3 over 2t squared minus 4t plus c, where c is a constant we need to determine. The question tells us that when t equals 0, the particle is not moving, meaning the velocity is also 0. So, c must be 0. The velocity equation becomes v equals 3 over 2t squared minus 4t. Next, we are asked to find the velocity when t equals 4. Substituting t equals 4 into velocity equation, we have 3 over 2 times 4 squared minus 4 times 4. So, the velocity at t equals 4 is 8 units per second. We now need to find the time when the velocity is 0. This means solving the equation v equals 0. Factoring out t, we have t times 3 over 2t minus 4 equals 0. Solving 3 over 2t minus 4 equals 0, we get t equals 8 over 3. So the velocity is 0 at t equals 8 over 3 seconds. Displacement is the integral of velocity. We integrate the velocity function and we get 1 over 2t cubed minus 2t squared plus c. When t equals 0, the particle is at a position of negative 10 units. So c is negative 10. The displacement equation becomes 1 over 2t cubed minus 2t squared minus 10. Finally, when t equals 3, the displacement from the origin is 1 over 2 times 3 cubed minus 2 times 3 squared minus 10. Simplifying, the displacement is negative 14.5, so the displacement at t equals 3 is negative 14.5 units from the origin. In this question, sketching the graph will help visualize the problem. We are given a straight line, L, and 2 points, A and B on this line. Point B is 5 units right and 10 units up from point A. We are also given that the ratio of AC to CB is 3:2. This means point C is 3 units to the right and 6 units up from A. Therefore, the coordinates of point C is 1, 8. Line K is perpendicular to line L, and we need to find the equation of this line. First, we calculate the gradient of line L. Since point B is 10 units up and 5 units to the right from A, the gradient of line L is 10 over 5 equals 2. The gradient of line K is negative reciprocal of 2, which gives negative 1 over 2. Since point C lies on line K, we can use the point slope form to find the equation of the line. Simplifying equation and rearranging the terms gives 2y plus x minus 17 equals 0. This is the equation of the line K. Moving to question C, point D lies on the x-axis, which means its y-coordinate is 0. Since D is on the line K, we substitute y equals 0 into equation of the line K, and we get x equals 17. Now, we need to calculate the length of the line segment CD. The difference in x-coordinate between points C and D is 16, and the difference of y-coordinate is 8. Using the Pythagoras theorem, CD squared equals 16 squared plus 8 squared. So the length of CD is 8√5. Next, we need to find the coordinate of point X, and the gradient of the line CX is the same as that of line L, which is 2. Then we have n minus 8 over m minus 1 equals 2. Multiplying both sides by m minus 1, we get n minus 8 equals 2 times m minus 1. From the diagram, we know that the triangle CDX is a right-angled triangle. Its area is 80 square units. Half times CD times CX equals 80. CD equals 8√5, and simplifying the equation gives us CX equals 4√5. By Pythagoras, CX squared equals m minus 1 squared plus n minus 8 squared. CX squared is 80. Substituting n minus 8 equals 2 times m minus 1 into the equation, and then we simplify to get 80 equals 5 times m minus 1 squared. Divide both sides by 5 and take square root. We are left with m minus 1 equals plus or minus 4. Since m is greater than 0, we take m minus 1 equals 4. Now we get m equals 5. N minus 8 equals 2 times 4. This gives n equals 16. The coordinate of point x is 5, 16. To find the value of y at x equals 4, substituting x equals 4 gives y equals 4 squared over 4 minus 3 root 4 plus 8. So the point has coordinates 4, 6. To find the equation of the normal at P, we first need to find the gradient of the tangent to the curve. We differentiate equation for y with respect to x. dy over dx equals x over 2 minus 3 over 2 root x. Now we substitute x equals 4 to find the gradient of the tangent at point P. The gradient of the tangent is 5 over 4. The gradient of the normal line is the negative reciprocal of the gradient of the tangent. So the gradient of the normal line, L, is negative 4 over 5. Using the point-slope form of the straight line, we get y minus 6 equals negative 4 over 5 times x minus 4. Rearranging the terms, we get the equation 5y plus 4x minus 46 equals 0. Moving to question C, to find the area of the region R, we draw the line L on the diagram. The intersection between the curve and the line is point P. We need to calculate two areas. The area between the curve and x-axis from x equal 1 to x equal 4, and the area of the triangle under the normal line. To find the area between the curve and the x-axis, we integrate the curve equation from x equal 1 to x equal 4. The integral of this expression is x cubed over 12 minus 9 over 2x to the 3 over 2 plus 8x. Substituting the limits, x equals 4 and x equals 1 gives an area of 73.75. Next, we calculate the area of the triangle. We first find the x-intercept of the normal line L by setting y equals 0. Then, x equals 23 over 2. The area of the triangle is calculated by half times base, which is 23 over 2 minus 4, times height, which is 6. The area of the triangle is 22.5. The total area of region R is the sum of two areas, which equals 96.25. We are given that the sum of the first term and second term of a sequence is 400, and the sum of the second and third terms is 100. We can form two equations. A plus AR equals 400, and AR plus AR squared equals 100. From the second equation, we can factor out R. So, R times A plus AR equals 100. From the first equation, we know that A plus AR is 400. Substituting and solving for R, we get R equals 1 over 4. We can substitute R equals 1 over 4 into the first equation to find A. Solving for A, we get A equals 320. The sum to infinity for a geometric series is given by the formula A over 1 minus R. Substituting A equals 320 and R equals 1 over 4 in the formula, we get the sum to infinity equals 1280 over 3. Moving to question D, for the sum of the first n terms of a geometric series, the formula is A times 1 minus R to the n divided by 1 minus R. We need to find n such that the sum is greater than 426.6. We know that A over 1 minus R is 1280 over 3. The inequality simplifies to 1 minus R to the n is greater than 6,399 over 6,400. So, negative R to the n is greater than negative 1 over 6,400. Multiplying both sides by negative 1 flips the inequality. Substitute R equals 1 over 4, and taking reciprocal to both sides of the inequality, which also flips the inequality, gives 4 to the n is greater than 6,400. Taking log base 4 to both sides, we have n is greater than logarithm base 4 of 6,400. Finally, n is greater than 6.3. Since n must be a positive integer, the least value of n is 7. We are given the equation log base a of 8 equals 3 over 4. This can be rewritten using the change of base property for logarithms. In this case, we can switch the base and the result. So it becomes log base 8 of a equals 4 over 3. We can now rewrite the equation in exponent form. A equals 8 to the 4 over 3. Then, a equals 16. Moving to question B, we change the base of all logarithms in the given expression to base 2. This gives us 3x log base 2 of x minus log base 2 of 8 plus 3x log base 2 of 8 minus log base 2 of 8. By using the power rule of logarithm, the coefficient in front of the logarithm can be moved as the power of the number inside the logarithmic function. Since we have the same base, we can multiply the numbers inside the logarithmic function. Now we have log base 2 of 8x raised to the 3x minus 1. This completes the proof. Moving to question C, we have proven that the left side of the equation is log base 2 of 8x raised to the 3x minus 1. The exponent can be brought down as a multiplier. Now we have 3x minus 1 equals 0, which gives x equals 1 over 3. We also need to consider another possible solution from log base 2 of 8x equals 0, which means 8x equals 1 and x equals 1 over 8. We are given that the vertical asymptote of the curve is at x equals 3, which means that the denominator of the equation becomes 0 at x equals 3. Therefore, the value of b in the equation must be 3. Now, we can substitute x equals 5 over 4 and y equals 0 into the given equation to find a. 5 over 4a minus 5 equals 0. Then we get a equals 4. Moving to question B, we need to find the asymptotes, x-intercept and y-intercept, to sketch the graph. The vertical asymptote is x equals 3. To find the horizontal asymptote, we look at the ratio of the coefficients of the highest powers of x in the numerator and the denominator. After simplifying, we find that the horizontal asymptote is y equals negative 4. The x-intercept occurs when y equals 0. Substituting into the equation, we find that x equals 5 over 4. The y-intercept occurs when x equals 0. Substituting into the equation, we get y equals negative 5 over 3. The curve will approach asymptotes x equals 3 and y equals negative 4 without touching them. The graph will have one branch in the upper left part and another branch in the lower right part. Moving to question C, suppose we want to find the intersection points between the curve C and a line L. To do this, we can substitute y equals 4x minus 5 over 3 minus x into 4y minus 7x equals k. Multiply both sides by 3 minus x. To eliminate the denominator, we get 16x minus 20 minus 21x plus 7x squared equals 3k minus kx. This is the quadratic equation that can be rearranged as 7x squared plus k minus 5 times x minus 20 minus 3k equals 0. To ensure there are no intersection points, the discriminant of this quadratic equation must be less than 0. The discriminant is given by b squared minus 4ac, where a equals 7, b equals k minus 5, and c equals negative 20 minus 3k. So, we solve the inequality k minus 5 squared minus 4 times 7 times negative 20 minus 3k is less than 0. Simplifying the expression gives k squared plus 74k plus 585 is less than 0. We can factor his as k plus 9 times k plus 65 less than 0. Thus, k must lie in the interval between negative 65 and negative 9 for there to be no intersection points between the curve C and the line L.